Hello kids, today we would be doing Java revision part 2. Last time we saw some of the basics, today we will continue. Let us see what is in a variable. A variable is a named memory location in which data can be stored. We have written so many codes and we know that integer a, where a is a variable name, float b is the variable name, and type, that is data type, is float. This is how we give a data type, and this is how it can be initialized. If we have already once written integer a, we can just write a is equal to 10, or you can combine both of them and write down integer a equals to 10 inside a method. Okay. Next is typecasting. What is typecasting? The process of converting one data type to another is called typecasting. We have learned two types of typecasting, explicit and implicit. Implicit typecasting is done when the computer or the processor is going to convert the data type on its own without the intervention of the programmer. Like when I say integer a is equal to 55 and double b is equal to 4.5, and I say double sum is equal to a plus b, automatically value of 55 turns into 55.0, both are added and the sum resultant data type is double. Typecasting always happens from the lower size data type to higher size data type, that is from integer to double, not the other way around. Explicit data type explicit typecasting is done when I am going to convert some data type to some other data type exclusively by informing the compiler or the processor that what data type I do want it to be converted into. Moreover, there are chances that the value may lose, or the whatever value you want to change may lose its decimal point or some other values. Let us see an example. Integer is 5, here the second integer is 2, and I am writing double ratio, that is I am going to divide number of boys and number of girls and convert it into double. If these two were double and I converted, then there were chances that I may lose the decimal point value. That is if I convert double into integer. Next are static and non-static variables. We have discussed this in class. Even then I am explaining you. Static variables belong to class and non-static belong to instant variable. Static keyword is used when I am using a static variable, and no word is used, not even static or any other, then it is a non-static variable. There will be only one copy of static variable per class, whereas in non-static there will be a copy of variables in each and every object, or each and every object will have its own copy of variables. When we are trying to access a static variable, we have to write class name, and when we are trying to access non-static variable, we have to create an object, then write the object name and try to use it. Let me show this with the help of an example. You can see in this code I have two variables, integer x and integer y. X is a static integer, whereas y is non-static, nothing is written before it. Now when I am trying to use x, I can change it directly, because one more rule, in a static method you can only use static variable, so y cannot be accessed over here directly. So what I did is I can change x, I changed it inside the method, and when I try to see, either I can write directly x or I can write the class name dot x. But when I want to use y, I have to create an object with the new keyword, and it is then I have to write the object name dot y. Now when I am going to run this, it will give me the output saying that static number is 12 and the other number is 0. I had not initialized, so the default value 0 for integer is displayed. Moreover, when I create an object of it, that is new static example, I am giving it 1. When I try to see its values, you can see I can see each one of them will be having 0 value and integer x. If I create one more, I'm creating one more object. It is also having its own copy of integer y. Whereas when I right click, x cannot be found because x is a static variable and it is automatically available, and only one copy exists for the entire show static fields. It is showing me that x is a static field and this is a non-static field. Okay. Now let us see some decision making statements. We have learned this in 11th standard. If are of 3 type, if can be written without any else if and else. This is an if. The expression has to be a Boolean value. If is a keyword, expression is a Boolean value. Statement 1 and 2 are the statement within the bracket. If I am going to write only one statement in if, then I need not write a bracket. I can directly write the statement. Only one statement, you do not need curly brackets. This is the other version. If and else, where if and else are keyword, expression has to be a Boolean value. It is having 2 statements in if part, 2 statement in else part. If I am not going to write only one statement, I can skip writing the curly brackets. This is the third one, that is if. One is only if, second is if else, and the third is if, else if and else. Any number of else if can be written. Expression 1, 2 and 3, all 3 are Boolean values. This is having 2 and 2 statements, and else is also having 2 statements. Again, if I have only one statements, I can ignore or I can decide not to write the brackets. This is a switch case statement. In switch also, we have an expression which is Boolean, which is the keyword. Case and default are also case and default are also keywords. Here constant 1, constant 2. Expression is not a Boolean value, but it is either an integer or a character. Constant 1 and 2 are also a integer or a character literal. Okay. Case, all the cases should be followed by break statement, or else if it enters the first case, it will still execute the second, and default is executed only in the condition when none of these cases turn out to be true. This is the iteration statement, that for statement. We have used it to print many numbers. Here we are, for has 3 parts. For is having an initialization which is executed only once, a checking condition executed every time before executing the statements inside the loop, and increment which is executed at the end of all the statements which are present in the block. You can also decide to write integer I is equal to 0 before for. In that case, a semicolon has nothing before it inside the for loop because initialization has been moved outside. I'll show you this with the help of an example. Here in this class, you can see that I have moved the initialization part before the for loop and the increment part inside the for loop, and I have to keep the condition part over here. So when I run this code, it is still going to function like any other code. You can see the output. This is the output. I think that's all for today's lecture. I have completed briefing 11th standard, whatever we have learned, or 11th standard syllabus. Now I'll be starting with new topic, and I would also like to take a Zoom class next week. I'll let you know the schedule. That's all for today. Thank you, kids.